I'm working for ESA. I'm a mission manager for a satellite. And we are in this talk, we are 4 people to make a presentation to show how we used Helix Nebula, the science cloud or the marketplace, to establish information as a service based on Earth science, on the supersite earthquake and volcanoes, and how this has been introduced now the first time as an info service. So the co-presenters is Antonio Cuomo from CGI, so a big company. Francesco Casu, CNR in Italy, they are a research institute, and Emmanuel Mondon, he is an SME value adding. So that's the agenda. I don't want to steal the time on the info as a service. I make a very short introduction. So you see here the value adding chain from enterprise SMEs, the people who create an environment that people can create value, scientists or business can go on it. A scientist will see on this platform massive data, all data available, massive computing tools, visibility to peers, knowledge and other data to create further knowledge. And then you see the commercial SME who shows the value creation chain from the beginning up to the very end, and how science can seamlessly move into business and become an innovation engine for Earth science, for example. And then I make one short summary. So the very short introduction is, so as a satellite operator, we of course have a data source. We've got a satellite, EMBL, CERN have different data sources, but data reception, processing, dissemination, archiving is all the same. So we use it, Helix Nebula, as a commodity. So because we have a different scale of data, of processing, we focus on our second task to stimulate a balanced development of science, public utility, and commercial applications. And that's what you also can see throughout the talks right now. So that's the way we're working right now with our data. So we have calibrated data, validated products that we have to give to the users. We use the landlines. We use physical media for mission lifetime data sets, a couple of tenths of terabyte. Or for people who are living remotely, we used satellite links, which are also pretty low. This was a system we are running since 20 years, starting in 1991, when postal service were the main service to deliver products. This doesn't work anymore. We get more and more satellites, sophisticated satellites with far more data volume. They cannot be downloaded anymore. Cross-domain research becomes more and more important. If you just consider climate change, where we are taking the measurement of the Earth, the impact on Earth science with life science, so there's no way you can collect all the data and download. And then we want to create incentives to upload information, data, tools, IPRs, developed over the last 20 years of other communities. So we want that people upload their ideas, work on the environment instead of downloading data. So we've created within Helix Nebula this kind of virtual workbench. So this has been created by ESA. This will be repeated in the other talks also. So this virtual workbench on Helix Nebula shall provide a new way of working. So on this one platform, you have visibilities instantaneously on all ESA data, seamless access to the data and to other data tools. We're collaborating with in situ communities in Europe, in the US, and globally, especially earthquakes and volcanoes are global phenomena. You have visibilities on other IPRs. You have visibility on peers. What are they doing? Are there some new tools available? You discover every day new opportunities. Maybe funding agencies are interested to look into it and saying, I might be interested to fund in there. And it's an incomplete list, and just to give you an idea. And I pass further on to Antonio, who presents the technology part.
Can you hear me? Okay, what I'm going to provide you is a perspective from the operations of the service. So essentially for us, we must move from the dissemination perspective that has been used in ESA to distribute the data to the scientists to an exploitation perspective in which the scientists are able to work on the data directly on the platform. So we must enable not only the sharing of data, but the moving of calculation near to the data instead of data near the calculation. and the support for scientists and industry to work together on this platform. So for the data, we have the Virtual Archive 4 system, which allows to share on multiple clouds all these satellite products, especially radar products from ESA past and present satellites. We must leverage HNX to perform batch processing of data directly on the cloud, and we can provide to the users on the platform virtual desktop that reside on the same cloud where the data is, or on a different cloud, but leveraging the giant infrastructure, and so being able to process the data directly on the platform. This is the data perspective. We start from here. The Virtual Archive allows to search for these satellite products and to provides a uniform access to that. It is a modular system in that it is composed of a catalog and several data nodes which are independent. We are able to scale up the size of the archive by creating more data nodes. This service started as a service on a hosting platform. Then the evolution of the service was to move the data nodes on the cloud. Then we are now able, through HNX, to have multiple data nodes on multiple clouds, and they can interoperate. And also leveraging the Giant partnership, we can provide to research institutes which have interesting data to share them on the Virtual Archive as a new data node, assuming that they are on their research institute is on one of the multiple national research networks. So we can create a full distributed data ecosystem. But this is not enough. This is still dissemination. To have exploitation, we must also provide the processing on the cloud. And we do this in two ways. We have a processing on demand infrastructure, which allows to execute processing services leveraging the processing power and Earth observation data. But it was in the past limited to the resources you see in the bottom that could be provided by ESA. Now we are extending this approach, leveraging the Xnebula marketplace. Resources are not bound to be provided by ESA, but can be provided by all the cloud providers. So we can essentially move, extend the batch processing on the cloud. How can we do this? With the blue box approach, we are able to buy the custom virtual machines, and in this way we can dynamically modify the base virtual machine images to create our own ESA cluster image for processing on demand. And we can also deploy multiple coordinated virtual machines. This is very useful because through the blue box we are able to contextualize dynamically the cluster so that each virtual machine knows where are the other virtual machines, and the cluster front end knows how many worker nodes it has available and can communicate with the worker nodes. This is all provided by the unified interface through which we interact with all the cloud providers. So this is where the Supersites Exploitation Platform pilot lives inside HNX. It's in the marketplace as a project. In this project, we can instantiate clusters made of front ends and worker nodes, but also virtual desktop for the users, which can use this kind of interactive processing, which complements the batch processing done in the cluster. So the toolbox is more similar to a virtual desktop environment in which the scientist can import his own algorithm and test using the processing power which is near to the data in the distributed platform. So the templates of the machine are here, and in the first example we can see how we can create a computing element for batch processing. Essentially we can deploy on multiple clouds, dynamically choosing the sites to fit the processing which is needed by the user.